Okay, great. Um, so, welcome to this day one of 3-day workshop on OpenMRS, specifically targeted towards uh, the MDR-TP program in Tajikistan, its deployments, its or business rules and customizations. A bit about me, myself. My name is Owais Hussain, and I am data scientist as well as in software domain. I'm software architect, and I regularly contribute to open source projects. I have been in the software industry for about 18 years now, and I have worked with people from 13 different countries, visited six of them personally. So it's been a lengthy journey, and I got my PhD in data science as well in 2023, and I also do a bunch of research work in the same domain. Now, as for the software engineering part, um, I design, provide, and support healthcare systems mainly. So mainly my domains are healthcare and education. These are the two main domains I have been active in, with a few projects here and there. But mainly I have worked in healthcare and education. And these days I'm also working on distributed systems, blockchains, etc. Now, as for the OpenMRS experience, I have been working on OpenMRS for more than 10 years now. So I've been following plenty of OpenMRS's advancements, the regular updates, the versions, or what the community is doing, etc. And upgrading legacy systems, migrating legacy systems into OpenMRS migrations, integrations, all in local settings as well as on national scale and sometimes multinational scale as well. Also, I am a co-founder and CEO of E-Squared Systems, so the company that's providing support for this program. And these are my areas, mainly public health. And in terms of technical stack, the technical skills, I work mainly in Java and Python, and also JavaScript, also R, but those are not like primary focus for me. This entire program is going to be in Java and Python as well. So for Java, the framework we use is Spring, and in Python we're using Django, as we will learn down the road. And also I help integrating systems and design APIs for the integrations. So there in this project as well, there was a major integration with the lab system, which I was also part of to support that. So this is a short brief about me. This training, this 3-day workshop is going to be conducted in a particular format. It's going to be online, and all the content will be recorded. So you have the prior intimation here, and we will be providing these recordings later at the end of the sessions. There will be a bunch of hands-on exercises as well to make sure that all the content has been successfully conveyed. It's going to be interactive. You're open to ask any questions in the middle, should you have any. And we are going to follow the given schedule all 3 days. So first half is going to be 9 a.m. in the morning to 10:15. We'll take a half an hour tea break. Then and resume at 10:45, and from 10:45 all the way to 1 p.m. We're going to continue our second half, and then there's going to be a lunch and prayers break. We will resume again at 2:15, and then this will be our third half, which will end at 4:30 p.m. So this is going to be roughly the schedule for the trainings. Now, the scope of this workshop is as such. We are going to be working on migration of the legacy tail-end ETL process into Python. I will explain it as we move forward. So this is, first of all, is ETL processes, and the other second objective is going to be upgrading the OpenMRS, customizing custom modules, how to deploy them, and how to enhance its API from within the OpenMRS. Then there's going to be a performance optimization. It's going to be a subtopic. This is also covered. How we can tune OpenMRS and database to be able to work on scale. Then there's Docker. How to deploy on containers, this entire suite. And we are going to be using Docker and Docker Compose. Then when as we are running in production, so how to provide support in that running system. And finally, all the knowledge transfer and be able to build local capacity to carry on and support this whole program we developed over the years. Now, how do we know that the workshop is successful? So there's going to be a success criteria, meaning every participant in the workshop should be able to create, build, test and deploy this one task called patient summary independently, and this one single task is going to cover end to end almost all topics. So if you are able to create a patient summary, meaning you are tapping into almost every corner of this project. So if you're able to do this, then it means you can the workshop is successful and the objective is finished. So this is a bit about the program and myself and how we are going to commence it. Let's move on to the main course. While I shall load the content. So let's talk about the agenda for today. Day 1, we are going to cover OpenMRS itself in complete detail. So this involves what OpenMRS is, its metadata, its data, its API, and how to interact with OpenMRS as a regular user. So it's going to be it's not going to be programming today. It's important to understand the OpenMRS as a system before we dive into any systematic changes into it. So that's our agenda for day 1, and this I would say is going to be the most important part of the training, something that cannot be covered easily. So our agenda is like this. We are going to see what OpenMRS is, why is it being used, and where are we using it. Then we'll cover its architecture. We'll talk about the data model in detail. There is a concept called concept dictionary. This is yet another critical aspect of OpenMRS, and then we'll talk about further settings, how to customize its properties. Finally, we'll talk about cohorts and OpenMRS reports, and we'll end with the REST API, which is again another very critical part of this whole thing. So all in all, this is going to be our day. Let's begin talking about OpenMRS itself. So OpenMRS is an open source free medical record system, OpenMRS Open Medical Record System, and it was built by PIH and in collaboration with with another institute, and since 2004, it's been 2026, it's been growing, and literally thousands of developers and contributors have joined in, made several contributions in several areas, and it's just one system. It is a flagship system, meaning in the open source domain, this is the best OpenMRS EMR you get. So OpenMRS itself is not a product per se, right? It's you can think of it as a horizontal platform, a foundation on top of which you can build further applications or you customize it. So this is more about configuration than rebuilding anything. OpenMRS gives you a solid foundation and enough support to configure according to your needs, be it a small clinic or a tertiary hospital or even an entire you can say healthcare system. It does have a few it does lack a few things, like it doesn't have very strong accounts and finance support, which you obviously would in a hospital. But other than that, as far as the patient data is concerned, OpenMRS covers pretty much everything. So this is one of the attributes. Now OpenMRS is upgrade safe, meaning its schema in its database, it has some core tables which do not change, meaning if you are not changing your schema, your database, then it is very easy to make it backwards compatible and forwards compatible and integrate with other instances. So one deployment of OpenMRS can talk easily with another deployment of OpenMRS, which is why this has been chosen. You can easily transform from like a very old version into a very recent one, which we are doing in this project as well. Now as for the vertical features, meaning so we have a foundation, and then for that foundation we provide for further applications, further customizations. These are called modules, and every module is just a module file. It's a zipped file, and you can deploy it on the fly. Like in a running server, you can add new features, new modules, without breaking the existing system, without disrupting the function, the ongoing operation. And the module we are going to be discussing in detail, the MDRTB module, that's also one of the examples. It was built for OpenMRS and deploys on top of it. So we have a foundation system and then a module which supports the MDRTB program. It is also interoperable, meaning it follows certain international standards, especially HL7 and FHIR first. And because it is following these standards, it is easy to integrate OpenMRS systems with other international systems. So for national healthcare programs around the world, it is easy to communicate, integrate with them, because this standardization exists. So any system which is HL7 compliant is OpenMRS compliant as well. There's a dictionary of terms, of terminologies called concept dictionary, which we will come to in this day one. And there are certain standard dictionaries like SNOMED and ICD-10. We will talk about this. Basically, OpenMRS is highly interoperable. We can integrate with pretty much every major healthcare system in the world. Then finally, it is community backed. So OpenMRS has a very strong community, very supportive one, and you will also be creating OpenMRS IDs and joining their community over Slack, and they're quite helpful people with there. So everything that happens in OpenMRS and will be happening in OpenMRS, that is covered within the community. It's communicated and documented. We have an OpenMRS talk, which is like a forum where you can post your issues and you'll get responses, more like Stack Overflow. So you will see that almost all major problems we come across have already been covered over there. Somebody asked and faced those troubles we are facing, or wanted to do certain modification which was already there in OpenMRS. So the first, if you want to make any change, the first place to go to and talk about it is OpenMRS talk. Then there's a detailed wiki, and OpenMRS wiki is also quite comprehensive. You have documentation about the core system as well as all community supported modules, and that wiki is so dynamic. Most of plenty of its content is self-generated, auto-generated, so it gets updated every time there are changes. And you will also see a whole trail of wiki from the previous versions as well. So it's not like that the documentation is updated and you don't get the historical trail. So irrespective of which version you are on, wiki is your first guide on how to use it, how to modify it. Then finally there is an issue tracker. They're using OpenMRS uses Atlassian's Jira. If you run into any bug, any trouble, that's the place to go. Bugs, changes, enhancements, these are also done by community. So it's not like I ran into a bug and if I post it, I cannot assume that it will be solved the next day. So somebody in this community will pick it. These are all volunteers, by the way, and resolve the bug. There's a whole process. There's a review. There's assessment, impact analysis. All of these processes are performed, and then on top of that, you get that issue resolved. If you have any enhancement to propose as well, go ahead. You can do that. And OpenMRS community welcomes if you want to contribute. So you run into a bug, you are trying to solve it yourself, you're welcome to do so. There's just a formal process. You will post the issue, and plenty of it. After you fixed it, the OpenMRS community will handle the deployments and updating to the artifact, etc. So the community support is very strong in OpenMRS, unlike many other open source systems. Now, OpenMRS is has been existing for for more than 2 decades now. It's been tried, tested, and trusted in 40 countries and counting. And mostly, the strength is it has been proven to work well in low income and developing countries where you don't have very strong infrastructure, internet connections, beefy servers. OpenMRS works without those as well. So the digital footprint, the requirements to operate, they are not really hefty. You can work with very modest basic systems and work effectively. Now, as for Tajikistan's version, so we have an OpenMRS for MDR-TB, National MDR-TB program, and that is one source for all the clinical data around Tajikistan to fetch and work on patient data as far as the MDR-TB program goes. Now, this whole program, it has 3 different components. Historically, there used to be only one module. So there was OpenMRS and Tajikistan's MDR-TB module. First, the MDR-TB module, it was customized for Tajikistan. This is about some 17 years ago, in I think 2009 or 2010. This was very first time OpenMRS was adopted and a module was customized for Tajikistan program. From that point onwards, there have been 2 major revisions. So one was around 2013 or 2014, where this custom module was enhanced. The ROS program, the DRTB program were added. The lab results, those were introduced. Custom reports were built, and at that time, this module, which was basically a community built module, was heavily customized for Tajikistan. Meaning now we have a module for OpenMRS which is built only for Tajikistan. So therefore, this module is not compatible with the main primary community module or any other deployment. It's very much like built around Tajikistan and settings over here. And support for Tajik language was also enhanced. So OpenMRS by default did not have Tajik as among the languages it supports. There was Russian but not Tajik. So this was added. And then later, roughly around 2022 to 2023, there was yet another revision, and that was the last major milestone we achieved, in which we further enhanced OpenMRS and upgraded its version from legacy 1.6 to 1.9 and then further from 1.9 to 2.4, because 1.6 was no longer supported. Even 1.9 was no longer supported, but to jump to version 2, you needed to be on the last version of OpenMRS 1. So the last one was the most recent was 1.9, meaning you jump from 1.6 to 1.9, and then from 1.9 you upgrade to 2.4. That was the path. So we did that, and it went for more than a year. and it also involved creating another interface from scratch. So the web application you see today, it's another app purpose built for specifically for the MDR-DB program, because OpenMRS's own legacy UI was not very convenient to work with. And also another reason was to be able to broaden the support for developers. Nowadays Java is becoming rare. Not many developers are opt Java to as their primary programming language. Mostly we see Python and JavaScript. So this web app was built on Python because we wanted something that is also data centric, and also where you will find abundance of developers knowing that language. So Python was the go-to language, and then Django is a framework for Python, and a quite mature one. Django has been existing for, again, it's been about good 12-13 years at least for Django. So we have Python and then Django, and on top of that we built an entire user interface. And basically this web app itself does not have a database. So the core system, the repository, the storage is all OpenMRS. The web app talks to OpenMRS and fetches data using its REST API, which we are going to talk about as well. Now, there is an ETL job that too is in Python, and that job migrates data from the production server into the latest schema of OpenMRS, latest version of OpenMRS. So we are targeting OpenMRS version 2.8, which is the latest one supported, so that we are still supported by the community for good 3-4 years down the road. And since it's the latest one, it does incorporate plenty of tools. We will talk about that later as well. Now, at first, this data migration was performed on Talend, TALAND. Talend used to be a system, an open source free tool for data migrations, ETL, data warehousing, etc. But it was later became like the open source, the community version was phased out, and it's now a proprietary tool, a paid one, and not cheap at all. So this whole project of ETL, that had to go, and now we, instead of picking another tool, we have just simply moved to another Python project. So there's a project called OpenMRS MDR-DB ETL, and now in our stack, which does exactly this. It picks data from the production and loads into, after transforming, loads into the current version, which is version 2.8. So this task was done literally it was completed in June, and we have not yet the trainings which are happening are not this on this version. It's still going through testing, but that task is complete. The project is ready. If there is additional data, it will be added, more jobs will be added to the same project, but other than that, this project is complete. Now, apart from these three components, the OpenMRS deployment for Tajikistan also has a bunch of more modules. So there is core OpenMRS, and then as we spoke, we add custom modules to enhance or to add more functionality that we need. So the most important one is address hierarchy. Now address hierarchy is required to define the geographical hierarchy of addresses. And now as you can see, in Tajikistan, OpenMRS is not deployed in one single facility. So there's a whole hierarchy we have to define. There are so regions, then sub-regions or districts, and within those districts we have health facilities. To support that, we need address hierarchy module. Then there's an HTML form entry module. HTML form entry module is your backup plan. It's the fallback thing. Sometimes what you do is you have some customization for a very brief amount of time. So for example, you are running an outreach program which is, say, screening for new TB cases in prison camps, in prisons. So for that, it is not feasible, it's not the best course to add new forms and new data, customize the whole web app. Instead, what we can do is literally in a single day create an HTML form and provide it to the team, and then that HTML form can be used for data entry purposes for such bespoke programs. So HTML form entry module is there, reporting module to generate all the reports. Of course, we're gonna come to this later. Then there's ID generation module. So identity is a major thing in OpenMRS. We don't have one single identifier for patients. So there's a generated ID and another assigned ID, which you can also think of as MR number. Actually, these are MR numbers, and we will talk about these MR numbers in the systems in a Tajik deployment shortly. So this module was required, and another common lab module. Common lab module is another custom module which is really handy for lab results. So there's a whole flow that you order a lab test or a group of lab tests, then the results, the samples are collected, the results arrive, and those are recorded. So this module supports that out of the box. And then finally, and most importantly, OpenMRS does not have a built-in REST API. There is a separate module which provides the REST API. So it's called REST Web Services module, and you can operate an entire OpenMRS system without this REST API. That will be the default OpenMRS, but it can only work for like one single hospital or a clinic or short or small facilities. To be able to support a program on national scale, you need a REST API so that you can talk with other systems, just like our web application is talking to the main core OpenMRS. So I'm only speaking about this briefly at the moment. We will come to the details and you will get to see everything in action as well. Now let's talk about OpenMRS's architecture. OpenMRS it did start modestly, but over the years it became a very mature system, and it now follows a layered architecture. So we have multiple layers. There are 3 layers. There's the database, there's a service layer, and a presentation layer. And this multi-layer structure, the architecture, is very handy if you want to support multiple platforms, operating systems, So OpenMRS can work with Linux, it can be run on Windows, it can be run on Mac OS, it can be run on Intel, AMD, you name it. So it is supported pretty much on every major platform out there, hardware or software or operating system layer. Now the data layer, let me just show you the picture itself. As you can see, the database, the de facto database is an RDBMS. So you have a relational database, and by default OpenMRS supports MySQL and MariaDB. But if you want to switch to some other database like Postgres, like Oracle or MS SQL Server, that can be done as well, because OpenMRS is not very strictly hardwired with one particular database. So you can work with a broad range of databases, but in our experience, MySQL Server, MariaDB, these are sufficient even for national skill systems. Even we've had a deployment in Pakistan. That was the biggest program I worked on, and that contained millions of patients. That consisted of millions of entries in patient table, and over 1 billion observations were there, and still it was running on one server with MySQL Server. It was optimized, it was tuned to be able to support it, but that was sufficient for our operation. So this was really important to note that MySQL Server, the default one, is a very strong choice. Only if you have a system which is like say even in Tajikistan, tomorrow you want to move entire national health system for all diseases, for all programs to OpenMRS. Maybe then you might need another database, a stronger one like Postgres or Oracle. But other than that, for the current scale, this is sufficient. Then there is a service layer. Now service layer is all Java. So you have this is where you define all your data logic, your business logic, and then your data transport logic. Basically, the data logic means all the data rules, the authentication, access, validations, persistence, all the data rules. These are defined in service layer, and MySQL database is driven by these rules. So we have Hibernate and Liquibase as our solutions for ORM, as well as the database change management. This is all in the service layer, which controls the database. So Hibernate is basically the core technology which enables any system to talk with more than just one type of databases. So this is service layer. Then there's business logic. All the business rules, all the healthcare related, patient care related rules, these are defined in the service layer, and this is probably one of the greatest strengths of the OpenMRS system. It has a very solid business logic. The service layer is very solid and very stable, highly tested. Very few bugs occur here, and it makes full use of Java. By the way, Java is, as you know, it's again when it comes to some serious enterprise solutions on scale, Java is the language to go to. It has always been for the past 3 decades or so. Then we have our transport logic, again in the same layer. Transport logic talks about exchanging data. It provides for example the REST API. That's about transporting. OpenMRS's own objects are heavy objects. They are not easy serializable or deserializable. So what we have is something called DTO. These are lightweight plain Java objects, and OpenMRS talks in terms of say JSON packets. Using those DTOs, they are then again transformed into OpenMRS's own models when you are communicating with an external system. But all of that happens on this transport layer. So we have REST controllers, we have legacy controllers, all are over there. You, as an external system, you don't talk directly with the OpenMRS database. You communicate with this transport layer, and the rest OpenMRS takes care of itself. Right? Now, then comes the presentation layer. This is where all the user interfaces exist. OpenMRS has gone through many iterations when it came to the presentation layer. So the most you can say changes happened on this layer. Initially, OpenMRS used to be just JSP pages. So you had OpenMRS core system, you had JSP, you have legacy controllers, and all the web pages were served via JSP. Now JSP is good for very basic stuff, but if you have custom styling or you can say advanced controls and widgets, HTML5, high support for HTML5 elements, JSP is not that strong. So JSP's main selling point is not the UI itself. It does support a very basic web interface, but that's pretty much it. Some layer of styling. So JSP this was the first issue, and then the other is you don't have many people who know JSP or very fluent in JSP. So that was another one, which is why OpenMRS moved from JSP to other solutions. There was HTML forms. There was another whole module called XForms. It still exists, but XForms is just another tool for drag and drop UI building. And externally, OpenMRS also supported InfoPath, and then it moved to something called reference application. Reference application came with a whole new suite of modules, new packages, another system. It's a whole system of developing the front-end applications. So reference applications worked for almost you can good 6-7 years, but then the problem with reference applications was it was quite complex. It was very complicated to work on. There were plenty of modules you had to deploy, support, and it's still ongoing. You can still use reference application, but OpenMRS's latest stack and the latest advancements suggested that RefApp is maybe not the best way to go in the future. So OpenMRS came with yet another venture called O3. So OpenMRS Frontend 3, this is, you can say, third major iteration OpenMRS is going through in terms of UI. Now O3 is very you can say clean, modern looking UI, and is very responsive as well, easy to work with. You can be a JavaScript developer, you can be a React developer, a Vue.js developer. O3 doesn't care. You can bring any JavaScript framework, work with it, and it will adopt. So instead of dictating the tech stack for UI, OpenMRS is now adopting all tech stacks within itself. So that's the whole idea for O3. But O3 is still in its infancy. It's not yet matured. It is not yet production ready. There's plenty to be done still. So for OpenMRS, it is not recommended to use O3 at the moment for production systems, but maybe down the road this will as it matures. One more thing, it is also supported on mobile platforms, so it's not just desktop. You can work off your phone, your tablet, any device. It's very you can say it's SP, a single page application. So this is all about the OpenMRS architecture. Now when it comes to deployment, there are basically two ways. The simplest one is to just pick the web archive provided by OpenMRS and deploy on your server which is running a Tomcat, an Apache Tomcat. So you pick this WAR file, you literally copy it to Apache Tomcat folder, start the server, and you have it served. In fact, our server at present, the test server, is also running a deployed WAR file. Now, having said this, we have moved to Docker with this new system, and it will now be a containerized deployment. The host database, the database itself will reside in the host system, but OpenMRS and the web app, the ETL tool, all of those are going to be working on the, just give me a second, something, sorry. So all of them will be deployed on Docker containers. It has been a pain because we would develop something that would work on our system, but as it is deployed, something would break and be not compatible. So to resolve all those issues, finally we have moved to Dockerized deployments, which we will also see in this workshop. So this is in one picture. This is the whole architecture of OpenMRS. We have our user interface on top, and then all the way you can have at the bottom you can deploy OpenMRS on cloud or in a rented data center, or even on your own premise, which I think is happening. There's an on-premise server in Tajikistan, which is where the OpenMRS is deployed, and from there the whole infrastructure is controlled over there. That's the architecture. We will now move to the most important, no, that would be a data model. So yeah, there's another thing something called pluggable architecture, modular design. So the core OpenMRS is there, as I told you earlier, but beyond the core module, so the core module supports what? Patients demographics, certain conditions, users, there are clinicians, health workers, receptionists, nurses, you have a concept dictionary, you have certain say drugs or lab tests defined. All of those are part of core. But beyond that, if you want to run custom programs, you need modules. So OpenMRS has this modular structure which allows hot deployments. So you don't need to restart OpenMRS to be able to add functionality. That is one of the biggest strengths of OpenMRS. It works like any enterprise system in which you can add or remove functionalities, change them, fix certain things without disrupting other modules, without disrupting the overall functions. So let's take an example of a hospital. In a hospital, you have you have a reception, you have an inpatient ward, you have surgeries, you have a whole lab, you have pharmacy. Say something is being changed in the pharmacy. Now, in order to make that change, does it make any sense to bring the whole system down and then make that update and then bring it all up? It obviously does not. So why should surgeries be impacted by something that is being changed in the pharmacy? So this is where the real strength comes from. OpenMRS is a plug and play, meaning your pharmacy module can be enhanced, it will be redeployed, and everything else will keep on working. Only that particular functionality, that particular module, that will not be working while the upgrade is happening. So it's all plug and play. So in a sense, you can say that in a hospital system, in a healthcare system, OpenMRS works as like an operating system, and the modules are custom utility software installed in that operating system. Now, these modules are packaged in a format called .omod. It's literally a zip file, and these modules can be stopped, can be redeployed any number of times. They are automatically started if you restart the OpenMRS server, but this can be controlled manually as well. Now, a module modules are not only to add new interfaces. These are not only for UI. All the 3 tiers you saw, a module can do that. So you have the interface, you can add custom business logic, you can add custom tables, and these tables will be added via Liquibase. When we come to exploring the code, I'll explain this. You can have more web pages, and even the modules themselves can have their own REST resources, so they can extend the baseline API and provide their own functionality, which the OpenMRS MDR-DB module also does. Then modules can have scheduled tasks like reporting module, and a module can further be connected with other modules and may also have extensions. So you have OpenMRS, you have an OpenMRS module, and you can also have an extension of that module. So that's how OpenMRS, that's how strong the modular design is. Now, at the heart of every module is an activator class. The activator class is what OpenMRS's own daemon process looks for. So when you install a new module, OpenMRS looks for that module's activator class and starts the module, like literally ignites the module from there. And from that point onwards, all the modules functionality is baked into the OpenMRS's own context. That's how it works. So it may appear as if OpenMRS, when you start it takes a while. So it looks like OpenMRS is a slow system, which is not at all the case. It is actually very efficient. But the fact that there's a daemon process looking for all the modules and their activators, it's starting all the activators one by one, making sure that one activator does not disrupt another, one module does not take the whole system down, one module does not break another module dependencies are there. All of these processes are executed for safety, which take extra time for OpenMRS to launch. Otherwise, OpenMRS is not slow at all. It's very very fast system. Now, our web application is a REST API client. The web application built in Django in Python is not an OpenMRS module. There is a separate OpenMRS module called MDR-DB module. That module handles the whole service layer and provides custom REST endpoints. These endpoints are what the web application uses to populate the whole UI. So this is the modular design. and we are going to take a half an hour break, and we'll come to the heart of today's session, which will be data model.